All right, guys, here we go. 3-5, part 1, looking at examples 1 through 3 today. The first thing we're talking about, directed line segment, and you see the definition up there. It's a segment that represents moving from point A to point B. Okay, so it's a line segment, but it has direction. So we're saying a directed line segment, AB, is going from A to B. Very specific about the direction that it's headed. What we're going to do with this, and it's kind of a tricky question here, but we want to find the coordinates of point P along the directed line segment so that the ratio of AP to PB is 3 to 2. So we want this point B somewhere in here, point P somewhere in here, so that the ratio is 3 to 2. Okay, 3 parts here, 2 parts here. Well, what that's telling us is we want point P to be 3/5 of the way down this line, right? Because here's 3, here's 2. So it's 3 out of a total of 5. So we want 3/5 of the way to B. That's where we want that point P. And that is right in the glare. And I apologize for that. Let's see if I can get that in a better spot for us. There we go. That's better. Sorry about that. So we want it 3/5 of the way. 3/5 of the way from A to B. So what we're going to do is we're going to kind of treat it like slope. It's related, but we need to know how much are we going over from A to B, and how much are we going up from A to B. So we're going to create that triangle. So going over, that's going to be from 3 out to 6. So we're going over 3. Going up, we're going from 2 up to 8. Okay, so that's a total of 6 that we're going up. So that's a total, that's 100%. That's the whole way over from A to B, is over 3 and up 6. Well, we only want 3/5 of it, right? We want 3/5 of the way, which is the same thing as 0.6. So what we're going to do is we're going to take each one of these numbers and times it by that fraction, that decimal. So we're going to times it by 0.6. We're going to times it by 0.6. So that tells me out of the 3 that I want to go over, the 3 that I'm totally going over, I only want to go over 3/5 of that. So I'm going to go over 1.8 of that direction. I'm only going over 1.8 there. Instead of going up 6, I only want 3/5 of that. So instead of going up 6, I'm going up 3.6. That's 6 times 0.6. So I'm going up 3.6. So I know I'm going to go over 1.8. I'm going to go up 3.6. But that's from the original. And so that's from point A here. So what I'm going to do is I'm going to take that original. Okay, I got a 3. I'm going to add that 1.8 onto 3. I'm going to add that 3.6 onto 2, because that was how much the x was going to go, that's how much the y was going to go. So when I add those on, that's giving me the ordered pair of 4.8 and 5.6. That's the ordered pair. That's this point P. And if we graph it, we have 4.8 and 5.6. That's going to be right around there. That's going to be that 3/5 of the way up there. Okay? It can be a tricky concept, so rewatch it and look at what I did. Make sure you have it in the notes. You can watch the videos on Big Ideas as well. They'll also have a video on how to do it. But that's our directed line segment. You're going to see a couple of those questions on the homework. Okay? The rest of this section, or I guess the next example, let me pull it up for us, deals with our theorems. And our theorems are talking about slopes of parallel and perpendicular. And we've talked about these before. Okay, we know the fact that slopes of parallel lines are congruent, or not congruent, are parallel. Slopes of vertical lines are, I just totally messed that up. Slopes of parallel lines are the same. Okay, they are the exact same. You can see it as an if and only if here. Non-vertical lines are parallel if and only if they have the same slope. So if they have the same slope, they're parallel. They also say vertical lines are parallel. They say that because we don't have slopes for that, right? They're undefined. So we also have to kind of throw that in. But we know the slopes are going to be the same for parallel lines. For perpendicular lines, the slopes are going to be opposite reciprocals. And they say the product of their slopes is -1. We know that as opposite reciprocal. Right? And remember, opposite reciprocal means if one slope is 2/3, we're going to flip that fraction and we're going to make it negative. Okay, so if one slope is 2/3, the other has to be -3/2. If the slope of a line is 4, then the perpendicular slope is going to be a -1/4. We're going to flip it, we're going to change the sign. So if one is, let's say, -5/4, we flip it, we change the sign, it's going to be 4/5. Okay, those are going to be perpendicular with each other when we look at those slopes. So that's our theorem, right? Those are our theorems about parallel and perpendicular. What we're going to do with that is we are going to look at the slopes of the lines, and we're going to be able to tell whether it is, oh, I put it in the glare again. Okay, so we're going to look at those lines and tell if they are parallel or perpendicular simply by doing slope. And remember, slope is rise over run. So if I want here, I'm going up 1/2. I know that's a slope of 1/2. Up 1/2 to the next point. That's 1/2. So I know those are parallel. Here is up 1/123. That's 1/3, not parallel, right? So that's what we're doing. Here, from point to point, I'm going down 2/1. So -2/1. That's going to be perpendicular to both of these. So you're finding your slope, rise over run, always count up and down first, then side to side. So that's our second example. And then the third, what we really need to concentrate on here, because it's probably the toughest of the problems, is going to be this one. Okay, so it says write an equation of the line passing through the point that is parallel to the line. So if it's going to be parallel to this line, we know it has to have the same slope as this line. Well, this is y equals mx plus b. We haven't used it in a while, but we know that the m is the slope. So if it's going to be parallel to here, it has the same slope, which means the slope of my new line is going to be 2. All right? So the slope is 2. I know the point that it goes through. It goes through the point -1, 1. Okay, so this is the information I know about my new line. I know it's going to be parallel to there, so it's got a slope of 2. And I know that it has to go through the point -1, 1. So using that information, I can use now point-slope form. Okay, point-slope form, I know it's been a while, but point-slope form looks like this. Okay, y minus y1 equals m parentheses x minus x1. So we plug in what we know. M, of course, is 2. And then we're going to plug in our point for x1 and y1. So x and y stay there. y1, okay, is going to be 1. x1 is going to be a -1, so that's minus a -1. Once we get there, now we can distribute 2x plus 2, add that over, and we get our new equation. Okay, so once you plug stuff in, it's just a two-step process. You're just distributing and then adding or subtracting that one number over. Okay, but we got to get these two values first, set it up into point-slope form, distribute, add or subtract, and we can simplify to get our new equation here. Okay, every one that you're going to see today is going to be parallel. Okay, the next example, which we're not covering in this section, talks about perpendicular. This is always going to be parallel. So all you're using this equation for, right, this given equation, is for that slope. Take the slope away, use that slope and the point that's given to put it into point-slope form. Okay, if you're unsure of how to do point-slope form, watch that again. Okay, look at where I plugged in the numbers and how I solved that out. Okay, that's the big part of here. Besides the directed line segment, which can be tricky, this is kind of the more important one. And we saw this last year, to be honest with you. We saw this last year. So that's what we're looking at. Hopefully we're good. Watch it again, ask questions, all of that, so that we are all set on this section.